All right, listen up, ladies and gentlemen. What I'd like to do is show you when to use elimination and how to use an elimination problem. Because what I noticed by some of the questions, Trevor, that some people are asking, thank you very much. What I decided from some of the questions that some of you are asking, Austin, was when students were looking at it, they didn't understand why use elimination or when to use elimination. I think substitution was pretty easy to spot when to use substitution, right? Yep. When you could solve for a variable, it's very easy to use substitution. So look at it. So when is it a good idea to use elimination, or how can we use elimination to solve our problem? So what I did was I wrote 4 problems up here. And I wanted you guys to understand that elimination deals with adding and subtracting the equations. But the idea of it is the same. When you have 2 equations, we haven't learned how to solve 2 equations simultaneously, right? So if you have 2 equations, we got to get them down to 1 equation. Then we know how to solve 1 equation. So to get them down to 1 equation, there's 2 ways we worked on it. Substitute 1 equation into the other is a Boolean. The next one was to add or subtract the equations. Now, it doesn't matter what variable you want to solve for first. But let's take a look at this first, all right? If I wanted to add these 2 up together, right? If I added these together, you guys would see, if I add these together, I end up getting 4a minus 0b equals 0. 4a equals 0. Do I now have an equation that I can solve for? Yeah, I can solve for a, though. I can divide and solve for a, right? So by adding, I eliminate the b, right? Because these are the same. One's negative, one's positive. However, let's look at this equation if I can subtract it. If I subtract these 2 equations, I get 0a minus 10b equals negative 40. Can you solve this equation? Yeah, you can solve for b. So why can you add or subtract both of these equations and eliminate a variable? The reason why this equation, it doesn't matter if you add or subtract, because look at the coefficients. For a, the absolute value of the coefficients are the same. And for b, the absolute value of the coefficients are also the same. The only difference is when they're the same and the same sign, I wanted to subtract to eliminate. When they're the same value and different signs, I added them to get rid of that value. Does that make sense?
Wait. So if they're the same sign, like if 2a were to be subtracting 5b on the bottom as well, it would be adding it. You said.
Say that again.
You said if the signs are the same, like if they're both subtraction. Yeah. Then you would add it.
Yeah, then you can add it. Yeah, if they're both negative, you could also add them as well.
Since it's different, you would.
He's not here today.
Subtract it.
Mm-hmm.
Okay, and I got another question.
Yep.
Is it always are they always the variables, are they always in the same order?
You might have to rearrange them. Sometimes they're not always linear.
But it doesn't matter if you rearrange them?
Nope. Just like 3 plus 4 is the same as 4 plus 3. As long as you keep the signs the same. So let's look at this one. Do I have coefficients that are the same? Yeah, I have 4 and 4. But since they're the same and the same sign, since the absolute value is the same and they're the same sign, am I going to add or subtract these equations? It'd be easiest to you just subtract these equations. All right. Now you guys look at this one, and we notice we have a problem. Because do I have variables that have the same sign? No. So what I need to do is I need to manipulate the equation so they have the same signs. So you guys could do, well, you could do substitution for this, yes. But you could also do it by elimination. The way to do this by elimination, Chase, the way to do this by elimination is you have to use a multiple, what we say. So what I can do is I can multiply. What if I multiplied the first equation by 9? If I multiply the first equation by 9, I get 9r minus 54t equals 44 times 9, which is, I don't know if anybody has a calculator. They can check that out. Then I have 9r plus 12t equals 0. Did you get that?
You said 9 times 44?
Yep.
396.
OK. So by multiplying the top by 9, do you guys now see now they have the same? And what would I do here? What could I do? You could subtract, right? You could just subtract the 2 equations. But that's not the only way. What about if you didn't want to get rid of the r? What if you wanted to get rid of the t? So if this is negative 6 and this is positive 12, that means they need to be the same. So what is the smallest number that would be the same? 12, right? So how am I going to multiply this to get 12? You could multiply it by 2. So if you multiply by 2, you get 2r minus 12t equals 88. And then you have 9r plus 12t equals 0. Well, now what do you do here? Instead of subtracting like we did with the r's, we're going to want to add. OK? Yes?
So always change the top equation?
Nope. Well, let's look at the last one then real quick. So let's look at this one. So this one, we don't have any of the same variables, do we, Isbelina? No. Or Trevor, do we don't have any of those? Well, can you easily add it by one number? No, not really, can you? But what we could do is if we multiply both equations by multiple, we can end up getting them to be the same. So you could think about this. Between 16 or 15 and negative 6, what's the least common multiple? 30, right? So you can multiply the top by 2 and the bottom by 5. Or you could do the least common multiple between negative 3 and 8, which would be 24, actually. Because 3, 16. 3 goes to 15. So you can multiply this by 8 and 3. And that's, that's probably a way, actually, I'd probably do it like this. So you'd multiply this by 2, and then this by 5. So then what you get is 30j minus 6k equals 258. This one becomes negative 30j plus 40k equals 72 times 5.
4K.
Huh? 40k. Thank you. So it'd be 144, 288.
Negative 72 times 5.
288, that'd be 360. And then from here, you guys could solve the rest of the problems. Because now, what would you have to do to solve this equation by elimination? You just have to do what? Well, since this is positive and that's negative, you'd want to add. OK?